So students, here Exs divided by Hys is equal to eta, that is nothing but root of j omega mu divided by sigma plus j omega epsilon. This has magnitude as well as angle because it is a complex number. Now, if you take the initial value of the electric field and initial value of the magnetic field, that is Hi0, then you get modulus of eta. Okay. So I have taken in that equation where Hiz, I wrote that Ei0 by modulus of eta is written as Hi0. From this Ei0 by Hi0 is equal to modulus of eta. It is like network theory. Voltage phasor by current phasor is equal to total impedance. Then modulus of voltage phasor divided by total voltage phasor divided by current phasor, total current phasor is equal to impedance that has magnitude and angle. Modulus of Vs divided by modulus of Is, that is nothing but you get Vm by Im is equal to modulus of Z you get. Similar to that. So total electric field phasor divided by total magnetic field phasor is equal to total impedance that has magnitude as well as angle. But magnitude of the electric field, that is Ei0, magnitude of the magnetic field, that is Hi0, that ratio gives modulus of impedance. Similar to this one, network theory. Because in network theory also, voltage and current carry the power from source to load, and in EM theory, electric and magnetic field carry the power from transmitting antenna to the receiving antenna. Okay. Now, we spoke of electric field equation, velocity, wavelength, magnetic field equation, impedance equation. Now we have to discuss how much power is carried by the electromagnetic wave. For that, before discussing the power, we have to see the formulas of Poynting vector. We will see. Instantaneous Poynting vector Poynting, he was a researcher, he has defined that instantaneous Poynting vector, small p of t symbol, it is a vector, small p of t symbol, is defined as small p of t is equal to E of t cross h of t. So you know this is a volt per meter and this is ampere per meter, and ultimately you get unit watt per meter square. Okay. So instantaneous Poynting vector, gives t means instantaneous. It gives instantaneous power crossing the area per meter square, means watt means that is power crossing the area, or otherwise instantaneous power through the area. Through means crossing. This you have to remember. This is also objective question. Okay. Next, in network theory, V of t into I of t gives instantaneous power, but there simply we say P of t. That is not a vector, but here E bar is vector, H bar is vector. For example, here Y, here P of t is power flow direction. It gives power flow direction. You should understand, if EM wave travels in x direction, power flows in x direction. If EM wave travels in y direction, power flows in y direction. If EM wave travels in z direction, then power flows in z direction. That means here power flow direction is also required. Given electric field and magnetic field, you need power flow direction also. That is why with two vectors, if you take dot product, you will not get the direction. Pointing defined pointing vector as electric field cross magnetic field, that gives direction also. Actually, practically, electric field direction, magnetic field direction, power flow direction, they are mutually perpendicular. So that is why if you take the cross product of these two, then you get the power flow direction. I will write that also later on. Now, the way you define average power in the network theory, similarly here also average pointing vector is defined. So these are all definitions I am writing, students. Now, average or otherwise mean, average pointing vector is defined as PAVG bar is equal to 1 by time integral, time varying from 0 to t, E of t cross H of t, and this is nothing but instantaneous pointing vector into dt. So 1 by t integral t 0 to time period, this is the instantaneous pointing vector is small p of t dt. So where small p of t is this one. This is also one of the formula. That means if you know electric field equation in time domain and magnetic field equation in time domain, take the cross product and find the integration over 0 to capital T time period, then 1 by t, you get the average pointing vector. Once again, the unit of this is watt per meter square. Okay. Now, dear students, in complex domain, that means phasor domain. In phasor domain also, these pointing vectors are defined similar to the network theory. Okay. Now, here in network theory, for example, complex power is defined like this: half into voltage phasor multiplied with the current phasor complex conjugate, or otherwise half into voltage phasor complex conjugate into Is. Now, real power or otherwise average power is defined as half into real part of Vs Is star. It is defined like that. Similar to this, actually, if you solve the power calculation in complex domain or otherwise phasor domain, that is very simple, very simple. For example, I will tell you that half into, in network theory, Vs is Vm at an angle of e power j theta of voltage um, uh, voltage wave angle. Current na Im e power j theta I. Now complex conjugate means theta I means angle of current waveform. Now complex conjugate means you get Im e power minus j theta I, and this is Vm e power j theta V. So real part half. So now that is equal to half Vm comes out, Im comes out, then real part of e power j theta V minus theta I. This is nothing but theta, that is the phase difference between voltage and current. That is also nothing but voltage of the angle of the impedance, actually angle of impedance. So real part of it is called simply e power j theta, real part. So Vm Im half. So that is nothing but half into Vm into Im into this is cos theta. Okay, theta is angle between voltage and current, or otherwise impedance angle. If you write in RMS that Vm by root 2 Im by root 2, so that is Vrms into Irms into cos theta you get. So if you want to convert only in terms of voltage, then Vm by Im is equal to modulus of impedance, dear students. Now in place of Im you put Vm by mod z, then you get half into Vm square divided by mod z into cos theta. Similarly, if you write Vm is equal to Im into mod z here, then you get half into Im square mod z, then cos theta you get. Okay. So in this way, similar to this, we get power equations in our subject also. Here, for example, here I will get half into, in place of voltage we get electric field. Electric field initial value is EI0. So half into EI0 whole square. Here modulus of impedance is there. In EM3 modulus of eta we get. Then cos theta, in that place cos theta eta we get. And power flow direction is z direction, because wave is traveling in z direction, then az we get, direction also we get. So by comparing with network theory, you can easily remember these formulas. Anyway, now I am writing the complex Poynting vector. So complex Poynting vector is defined as complex bar. Students, if I put P, bar means that is always average Poynting vector. Bar means direction is there. Okay, so that is defined like this: half into electric field phasor cross magnetic field phasor complex conjugate. That is also equal to half into, you can take complex conjugate for this one or otherwise for this one. So cross HS, this is watt per meter square. Okay. Now this is a complex Poynting vector. If you want average Poynting vector, you have to take real part. You can understand here in network theory why they have taken complex. When you take complex, then this what do you say, the sign of this becomes minus. Then you will subtract the phase of voltage and current. If you subtract the phase of voltage and current, that gives impedance angle. So here average Poynting vector is defined as P AVG bar is equal to half into real part of ES bar cross HS bar star, that is equal to half into ES bar star HS bar. Of course, you have to put real part, students. Okay, and watt per meter square. So in above equations, if you take real part, that gives average Poynting vector, and unit is watt per meter square. So these formulas also you have to remember. Now once if you have average Poynting vector, that unit is watt per meter square, then you dot product with the surface vector, then you get power crossing the surface. Power crossing the surface, that is also one of the formula. So average power crossing the surface, or otherwise average power passing through any surface, both are same. Average power crossing the area is PAVG. Bar is not there means that is power. Simply average power is equal to double integral PAVG bar dot ds bar. So you can see here, this is watt per meter square. Multiply with meter square, you get watt, that is power. So this is average power crossing the area, or otherwise average power passing through the surface of some area. Okay. Now anyway, if this is the formula, this one is the formula. If PAVG bar is uniform, then PAVG is equal to PAVG bar dot, it comes out double integral ds bar is nothing but s bar. Anyway, you have to remember this formula, dear students. So these are all definitions. I wrote here average pointing instantaneous pointing vector. Then after that I wrote average pointing vector. Time average pointing vector actually is this one. If you want, you can write here, this is a time average pointing vector. Time average pointing vector, this one. And this one is complex pointing vector. So this is average pointing vector. Real part is taken. Okay, if you want power, whatever you found average pointing vector here, you take that and ds bar. Dear students, with this whatever answer you get, same answer you get with this also, but the calculations are very simple in phasor domain. That is why we use this formula. Once again I am telling, whatever average pointing vector equation you get with this formula, same answer you get with this also. We are going to use this one because in phasor domain calculations are very simple. That is why. Now these are general formulas. Are you observing? Are you able to observe? We found electric field equation. Then we found magnetic field equation. You substitute electric field equation here in phasor domain. Substitute complex conjugate of magnetic field equation in phasor domain here. Then you get the average pointing vector. Then you have to remember the final answer. Don't bother about the derivation. Now I am doing the derivation. You keep watching now. Here we know that electric field x component electric field x component in phasor domain is equal to EI0 into e power minus gamma z, that is nothing but EI0 into e power minus alpha z e power minus j beta z. So and also here what do you say, a electric field phasor is equal to, if only x component is there, we write EXS AX cap we write. And similarly magnetic field y component was EI0 divided by modulus of eta. So that was e power minus alpha z e power minus j beta z, then e power minus j theta eta it was in phasor domain. Okay, so simply HYS is nothing but electric field phasor, this one. EI0 e power minus alpha z e power minus j beta z divided by eta. Eta means mod eta e power j theta eta, it comes to numerator. Now magnetic field phasor vector is equal to magnetic field component, that is HYS into AY cap. Now what is the HS star? That means HS star means simply HYS star you have to take, that is complex conjugate of this one. We can't take complex conjugate for the direction, it is meaningless. It is meaningless. Okay. Now you take the complex conjugate of this one, HYS star is equal to, and EI0 divided by modulus of eta e power minus alpha z. Wherever plus j is there, then complex conjugate is minus j. If minus j is there, then complex conjugate is plus j. So here minus j is there, complex conjugate is e power j beta z, and this one is e power j theta eta. Now what is the average pointing vector? This is the formula. So average pointing vector is equal to half into real part of ES bar, that is nothing but this one, EXS AX cross HS bar star, that is this one, HYS star, that is complex conjugate, AY cap. Now this cross is done only for directions AX cross AY, that is AZ. So here wave is propagating in Z direction, power also goes in Z direction. Now that is equal to half into real part of EXS, then HYS star, AX cross AY is AZ. So AZ cap goes outside. Now let us substitute the EXS here. This one is EXS. So that is EI0 e power minus alpha z e power minus j beta z. HYS star is this one. HYS star is EI0 divided by modulus of eta e power minus alpha z e power j beta z, then e power j theta eta. Okay. Now here EA0 into EA0 square, that comes out. So half into EA0 square, that is also written like this, and this mod eta is there, e power minus alpha z e power minus alpha z e power minus 2 alpha z, no complex term, so it comes out. Then e power minus j beta z e power j beta z e power 0 is 1. Then only complex term is this one, e power j theta eta. So it is cos theta eta plus j sin theta eta. Real part is actually cos theta eta, and here AZ cap was there. So here this is AZ cap. And now average pointing vector is equal to half into EA0 square divided by modulus of eta e power minus 2 alpha z, and this is cos theta eta AZ cap. So this is watt per meter square. Dear students, electric field is proportional to e power minus alpha z. Magnetic field is proportional to e power minus alpha z. But power is proportional to e power minus alpha z whole square, that means e power minus 2 alpha z. So power decreases faster than electric field or otherwise magnetic field. Okay. Now here, if you want in terms of magnetic field, then what you do, you have to use this E I0 divided by Hi0 is equal to mod eta, you have to use. So in this formula, in place of EI0, for example, in place of EI0, you put Hi0 into mod eta, then EI0 square means Hi0 square mod eta cancel. So you get half Hi0 square mod eta you get. So anyway, I am not writing that because you know this. So if you substitute this here, then this equation you get half into modulus of Hi0 square into mod eta e power minus 2 alpha z cos theta eta az. Oh, why to use that equation? In some cases in exam question, Hi0 is given and they ask you to find the power, then the equation is half into Hi0 square mod eta e power minus 2 alpha z cos theta eta. So here theta eta is phase difference between E and H, or otherwise angle of intrinsic impedance. So this is very important formula. You have to remember this one. Okay. Now average power crossing Z is equal to constant surface. Z is equal to constant surface for 0 less than or equal to A, comma 0 less than or equal to Y less than or equal to 0 less than or equal to X less than or equal to A, 0 less than or equal to Y less than or equal to B. That means there is one surface. That surface length in X direction is A, surface width in X direction, Y direction is B, area of the surface is A into B. So that is like this. For example, if wave is traveling in z direction like this, wave is traveling in z direction, then there is one surface like this parallel to x axis a units and then parallel to y axis b units is there. So like this it is there, okay, like this, and it is b units is there here. Now this one is a, this is b, and the area of this is a into b. Then that surface is like this, maybe at z is equal to 1 meter height, for example. Then 1 is constant, that is called z is equal to constant surface. For example, it is z is equal to 3 meters, then 3 is constant, then that is called z is equal to 3 meter surface. So this is the surface. Now how much power is crossing? Here wave is traveling in z direction, here wave is traveling in z direction. Then how much power is crossing this area like this? No, wave is traveling like this, and this is the area. How much power is crossing this area? You know what is this area in our calculation? That is receiving antenna area actually. So here we are sending here we are sending em wave like this. For example, here radio is there. So here radio is there, that radio has antenna here. Then whatever em wave, this is radio antenna, let us say, whatever power tries to cross this area, that much power is received by this receiving antenna. So that receiving antenna has area, that is this area actually. But here we are taking general area and calculating, but actually the meaning of that area is nothing but receiving antenna area, because we send electromagnetic wave, then that carries power. For example, it carries radio mirchi signal, etc. Then if radio is there here, then radio has antenna, that antenna has that the antenna has area. So whatever power tries to cross radio antenna area, that much power is received by that radio. So anyway, dear students, this has physical meaning, that's what I want to tell you. Average power crossing z is equal to constant surface for 0 x value 0 to a and y value 0 to b is PAVG is equal to, that means average power, is equal to double integral PAVG bar dot ds bar, that is equal to double integral PAVG bar is this one, half into EA0 square divided by modulus of eta e power minus 2 alpha z cos theta eta and az cap dot in z direction ds bar is dx dy az cap, dx dy az cap. So half EA0 square modulus of eta e power minus 2 alpha z cos theta eta, az dot az is 1 integral dx, x from 0 to a integral dy, y from 0 to b, students. So that is nothing but average power is equal to half into EA0 square divided by modulus of eta e power minus 2 alpha z cos of theta eta into, this is a into b. Simply average Poynting vector magnitude multiplied with area gives average power. So this is what that means. If em wave is traveling in z direction, this much power crosses the area, this much power crosses the area. Okay, magnitude of average Poynting vector multiplied with area gives total power crossing that area. This is the calculation of the power. Now almost we have completed the discussion. What is this discussion? You see, when electromagnetic wave travels, it has electric field. It has electric field. I am writing here. It has electric field and it has magnetic field. Then electric and magnetic field are linked with impedance. And while propagation, it has gamma, that is equal to alpha plus j beta. Propagation characteristics are decided by this one. It has phase velocity also, it has wavelength also, and it carries power also, average power, and we have studied all of them. So now what we have to do, we have derived these equations for general medium. For general medium means it may be air medium, it may be dielectric medium, it may be conductor medium, it may be magnetic medium. So it may be any type of medium. These equations are valid, which we have derived. These equations are valid for all the cases. Now what we do, what we have to do, if wave travels in air medium, how these equations look like. If wave travels in dielectric, if wave travels in conductor, then what happens to these equations? So we have to substitute the medium parameters in these equations. We will discuss that one. Okay. So dear students, let us write this. You see these theory points. So I want to save the time. That's why I wrote. You see types of distortions in the medium. You know that medium parameters are epsilon, mu, sigma, and whenever wave travels, frequency of the wave is also present. So if you see attenuation constant alpha of the medium is a function of frequency, then medium has frequency distortion. Then otherwise, if alpha is constant, we will see while solving the wave propagation in different mediums. For some mediums, alpha will be a constant. For some mediums, alpha will be a function of frequency. So if alpha is a function of frequency, then that medium has frequency distortion. Now, if alpha is a constant, then there is no frequency distortion. Okay. Now, if phase shift constant beta is nonlinear function of frequency, then phase velocity is equal to omega by beta is also a function of frequency, and medium has a phase distortion or otherwise delay distortion. If beta is a linear function of frequency, for example like this, so shortly we will see beta phase velocity is equal to omega by beta. For some cases we get beta is equal to omega root mu epsilon. That means omega is 2 pi f actually. So here beta is proportional to frequency. This is linear actually. So here beta is proportional to frequency. That means this is linear. If beta is a linear function, of frequency, then omega root mu epsilon, this cancel 1 by root mu epsilon. So it is a constant. Now it is not a function of frequency. So then it is constant actually. In this case, there is no phase distortion. For example, beta is a nonlinear function of frequency. Then what happens here? Frequency comes, f square also comes. Then here f is there. For example, here f square come and f by f square. So some f will be remaining. So then phase velocity will be a function of frequency. So in that case, phase velocity is also a function of frequency. In that case, there exists a phase distortion. Now, if the intrinsic impedance eta is a function of frequency, for example, intrinsic impedance is equal to root of j omega mu divided by sigma plus j omega epsilon. If sigma is there, then omega 2 pi f, it is also 2 pi f, then it is a function of frequency. In that case, medium has a selective absorption power distortion. For particular frequencies, that medium absorbs the power. That is the meaning. If eta is constant, for example, for any medium sigma 0, then j omega cancel. You get root mu by epsilon. It is constant actually. So there is no frequency here. We will study all those things. If eta is constant, then there is no selective absorption power distortion. Okay. Now, if you don't want any type of distortion, then alpha should be constant, velocity also should be constant, eta also should be constant. Then for any medium, if alpha, velocity, phase velocity, and here velocity means always phase velocity, and impedance should be constants, then there are no distortions. Example medium is air medium. For air medium, alpha 0, phase velocity is root mu naught by epsilon naught for air medium, that is light velocity 3 into 10 power 8. Then eta is equal to 120 pi, you get all are constants for air medium. Okay. For example, lossless dielectric medium also. we will study the different types of mediums. So in those mediums, if you get alpha, V, eta, intrinsic impedance, if they're constants, then automatically there will be no distortions in those mediums when wave is propagating. I will write here one more note regarding the direction of electric field, direction of power flow, and direction of magnetic field. Those three things. You see here, note I am writing. Now, Pointing vector is E of t cross H of t is equal to Pointing vector. Okay. Now, this has some direction. So, let us say A cap is unit vector in electric field direction cross A cap means unit vector in magnetic field direction. A cap means unit vector in power flow direction. Okay. Now, this looks like ये कैसे दिख रहा है आपको ax cross ay is equal to az, for example. Already you know what is the meaning of this. Ax cross ay is equal to az means x and y and z are mutually perpendicular, and also they are in the sequence. So that implies they are in the sequence. That means ax cap, ay cap and az cap, they are in the sequence. That is the first point. And second point is they are mutually perpendicular. Ax, ay, az, they are mutually perpendicular. These two things are correct actually. Okay. If any equation is in this form, then they are in the sequence and also mutually perpendicular. Similarly, here also in place of ax, a is there. Here in place of ay, ah is there. Here ap is there. Now, but the meaning of this is actually electric field direction unit vector, magnetic field direction unit vector, and power flow direction unit vector. They are in the sequence. And also second point is that AE cap perpendicular to AH cap, perpendicular to AP cap, they are in the sequence and they are mutually perpendicular. That is why AE dot AH 0, AH dot AP 0, AE dot AP 0. They are the properties of uniform plane wave. We will write them later on. So anyway, you have to remember this. Then, for example, what is the meaning of this, dear students? So I am putting this as a point 1. Okay. What is the meaning of this? This one. What is the meaning of this? Like this, AE and AH and AP. That implies if you want, if you take AE cross AH, then it gives a power flow direction. For example, if you take AH cross AP, then you get AH cross AP, then you get electric field direction you get. Similarly, AP cross AE you take, then you get direction of magnetic field actually. So, in any question, if you know electric field direction and magnetic field direction, you can find power flow direction by taking this equation. In any question, if you know magnetic field direction and power direction, you can find electric field direction from this equation. In any question, power flow direction, electric field direction is known, then you can find magnetic field direction. Okay. Here, dear students, where AE means unit vector, A cap means unit vector in electric field direction, and AH cap means unit vector in magnetic field direction. AP cap means unit vector in power flow direction, or unit vector in power flow direction, or otherwise unit vector in wave propagation direction. Dear students, if wave travels in z direction, then wave carries the power in z direction, because wave carries power. I told you yesterday one example. If bus is going, अगर गाड़ी है, if bus is going in x direction, then that bus carries all human beings inside that bus in x direction only, because bus is carrying the human beings. So wave carries the power. That is why if wave propagation direction is z direction, then power carried by the wave is also in z direction. That is why wave propagation direction and power flow direction both are same. So these are very important points there. So note 1 and note 2, you have to remember them. So actually no, you must know how to learn the subject. Wherever I do derivations, I am telling you no need. So then don't read them. And wherever I write note, you have to read them 4 times, 5 times, 6 times, depends on your patience. Then you can easily solve the question, student. Okay. So don't do opposite. You are not going to study the points in the note. Simply you are wasting time in doing derivations. Then there is no use. You are simply passing the time and you are not preparing for competitive exam. That is the meaning. So anyway, now here I will write one observation. For example, here radio Mirchi signal is there, FM signal is there, FM signal is there. That FM signal, it is in the form of voltage or otherwise current, then it is given to the transmission line conductors. We will study that also. Transmission line conductors, I will explain this in next chapter in detail. Now you are given them to the antenna here, antenna. Then this is called transmitting antenna. TX means transmitting. Short form, transmitting short form is TX. So transmitting antenna. Now from this antenna, EM wave is traveling like this. This is electromagnetic wave. Now we have seen this electromagnetic wave has electric field and magnetic field. And if electric field and magnetic field is there, you take cross product, then it has average pointing vector also. Now here for example, radio is there. That radio has one receiving antenna here. So okay, what is this? RX means receiving antenna is there here. Now this average pointing vector unit is watt per meter square. That average pointing vector hits this antenna area, then you get average power is equal to double integral PAVG bar dot DS bar. We have written that formula already. Now this EM wave, what is the use of this EM wave? It carries power from transmitting antenna to the receiving antenna. Now whenever EM wave is traveled, it travels in air medium, or otherwise it is also called free space, and in between so many buildings come. Then that building wall is made up of cement, that is dielectric. So that EM wave travels in the dielectric medium also. So that dielectric has two types. In the dielectric sigma is 0, that is called lossless dielectric. If sigma is present, that means conductivity is present, that is called lossy dielectric. And conductors also present, so conductor medium. So different types of mediums are present, conductor. And dielectric, it has two types, lossy dielectric and lossless. So lossless dielectric and lossy dielectric, two types are there. Lossless dielectric means sigma is equal to 0, sigma 0, and lossy dielectric means sigma not 0, and conductor medium. So whenever wave travels, that whenever wave travels, the wave means EM wave. Whenever EM wave travels from transmitting antenna to receiving antenna, it experiences different mediums like air medium, lossless dielectric medium, lossy dielectric medium, then conductor medium. Different types of mediums come. So now we have to put the separate heading and study what happens to electric field equation, magnetic field equation, velocity equation, wavelength equation, impedance equation, power flow equation. For all those equations, we have to write all those equations when wave travels in air medium with separate heading. What happens to those equations when wave travels in lossless dielectric medium? Then what happens to those equations when wave travels in lossy dielectric medium? What happens to those equations when wave travels in conductor medium? So we have to study them. That means already almost we have completed this discussion. But you write air medium parameters and lossless dielectric parameters, lossy dielectric parameters, conductor parameters. Simply you have to substitute those parameters in these equations. That is the discussion. Okay. So students, let us study the first case. First case is wave propagation in air medium or otherwise free space medium. So for air medium or otherwise free space medium, epsilon value is equal to epsilon naught and mu value is equal to mu naught and conductivity is 0. That means epsilon r is equal to 1 and mu r is equal to 1 actually. So these things you have to remember. So these are the medium parameters for air medium. Now we have written so many equations: electric field equation, gamma equation, velocity equation, impedance equation, magnetic field equation, average Poynting vector equation. We wrote general equations. You have to remember them thoroughly. They were in the box actually. वो डब्बा में थे, वो बढ़िया से याद रखना है. Now you have to substitute these parameters in those equations. Then wave propagation in air medium will be completed. Study of wave propagation in air medium will be completed. So now first one, gamma is equal to j omega mu sigma plus j omega epsilon. This is general equation. This is general equation. That means applicable for all mediums. Now for air medium, if you substitute j omega, mu is equal to mu naught, sigma is 0, j omega epsilon naught. So now this becomes gamma is actually alpha plus, I will write one more step. Students. So gamma is equal to j omega into j omega. So out of root j omega comes root mu naught epsilon naught. Actually it is a lossless medium, and if you see gamma is equal to alpha plus j beta, that is equal to j omega root mu naught epsilon naught. You compare both sides, then alpha 0 you get, and beta is equal to omega root mu naught epsilon naught. Alpha 0 means no attenuation. Or otherwise loss is not there, so it is lossless medium. Now if you see carefully, beta is omega root mu epsilon, this one. So that means in this case gamma is equal to j into beta. So this is gamma is purely imaginary. You remember this point. Whenever in transmission line also, in uniform plane wave also, in waveguides also, if gamma is purely imaginary, then that lossless medium. You have to understand that, student. So gamma is purely imaginary. That means only beta is there. Alpha is 0. So I am writing that point for lossless medium, gamma is purely imaginary because alpha is equal to 0, then only beta will be there. Okay. For lossless medium, gamma is purely imaginary, my dear friends. That means alpha is 0 for that. Now, already you know this equation. Simply we have substituted air medium parameters and we got alpha 0, beta omega root mu naught epsilon naught we got. Second one, intrinsic impedance is equal to, actually these equations no for air medium they are valid. Okay. Now eta is equal to j omega mu sigma plus j omega epsilon and a root. This is general equation. General equation means applicable for all mediums. Now for air medium, j omega mu is equal to mu naught sigma 0, so j omega epsilon naught, and ultimately this becomes j omega cancel, mu naught by epsilon naught. So this mu naught is 4 pi into 10 to the power minus 7. Epsilon naught is 1 by 36 pi into 10 to the power minus 9, and you get here 36 into 4 you get. Ultimately you get here, if it comes to numerator, 10 to the power 10 square you get. So out of root 10 you get here pi square, that means pi, so 10 pi. Then here 4 into 3 12, so 120 pi you get, and if you calculate this you get 377 ohms, and it is called as eta naught. Here no students, lambda naught, eta naught, this naught symbol is used for air medium. You remember that. Okay, this naught symbol is used for air medium, like epsilon naught, mu naught, they are for air medium. So now this is called as eta naught is equal to root mu naught divided by epsilon naught. Then you get 120 pi, and that is 377 ohm, all are ohm. It is called intrinsic impedance of air medium, or otherwise free space medium. You have to remember this one. It is real. That means theta eta is 0. Theta eta is 0. That means for this medium, E comma H are in phase. That means electric field, already I explained you, electric field has cause term, magnetic field has cause term. The phase difference between electric field cause term and magnetic field cause term will be 0. They are in phase. That means they have same phase. That is the meaning. In the power average power equation, cos theta eta is there, that becomes 1 actually. That is the meaning of that one. So here one important point I want to tell you. See, dear students, why I am doing this derivation. Derivations are not useful, but while doing derivation, we'll get some equation. We have to remember that, and we have to do some observation. What is that observation? If sigma is 0, then gamma becomes purely imaginary, and always alpha is 0, and this impedance doesn't have angle. That means impedance is a real impedance, real one, that is. Okay. So here you should not confuse this impedance is in network theory like root L by C. Mu means L, epsilon means capacitance, root L by C type. So root L by C is not a heat loss impedance. You should understand that. Simply that impedance, this eta is E by H. This impedance is useful to change electric field to magnetic field, magnetic field to electric field. That is the meaning of that one. Anyway, nobody will ask you that. कोई पूछेगा नहीं आपको. If sigma is 0 in any medium, then immediately alpha becomes 0 and impedance, intrinsic impedance becomes real. That is not a complex actually. That is the meaning. Now, what happens to the phase velocity we have to see. Third one, phase velocity. Phase velocity general formula is omega by beta. This is general formula. Now, this phase velocity for air medium omega, beta is omega root mu naught epsilon naught, that is equal to 1 by root mu naught epsilon naught, that is root of this is 4 pi into 10 to the power minus 7 mu naught, epsilon naught is 1 by 36 pi into 10 to the power minus 9. You get this 3 into 10 to the power 8. So ultimately, dear students, simply this is called as c here. C means light velocity. So c is equal to, you get here 1 by root mu naught epsilon naught, that is equal to 3 into 10 to the power 8 meter per second you get. So this is a velocity of light in free space medium. Okay. So when electromagnetic wave travels in the air medium, it has a phase velocity equal to the light velocity. That is the meaning of that one. Now, lambda formula. Lambda is equal to 2 pi by beta. So this is the general equation. So now if you apply the beta here, 2 pi divided by beta is omega root mu naught epsilon naught, and this is 2 pi divided by 2 pi f root mu naught epsilon naught, that is equal to 2 pi cancel. 1 by root mu naught epsilon naught is c by f. It is termed as a lambda naught. That means wavelength of the air medium or otherwise free space. That means when electromagnetic wave travels in air medium, that will have wavelength lambda naught. Here I told you naught symbol is used for air medium. So from this lambda naught is equal to c by here c by f. C by f. Wave length in air medium. Okay, this one. Now, what is the electric field equation? Electric field equation x component for wave traveling in z direction is ei0 e power minus alpha z cos of omega t minus beta z. This is actually general equation, dear students. Okay, this is general equation. But for air medium, this becomes ei0 alpha 0, e power 0 is 1. So now cos of omega t minus omega root mu naught epsilon naught beta is z. And this is also written in some books like this. Omega is pulled out, then t minus of omega comes out, z divided by 1 by root mu naught epsilon naught. It is written like this. So if you write like this, then ei0, okay, that is equal to ei0 cos of omega t minus z by c. This is light velocity, student. So like this is correct na? Here this is time minus time should be there. This is meter per second. Meter by meter second gives meter by meter per second gives second only, second minus second. That is correct actually. So why I am writing like this, in some books they give the equation like this, omega t minus beta z form. In some books they give like this, but you should not confuse. In some books they give in phasor form. So total equations are given in 3 forms. In phasor form, and in time domain form it is beta. In time domain form, in velocity form also it is given. So these equations are for which medium? Air medium. This is general equation. Similar to this, you can write what do you say? Magnetic field equation. Magnetic field y component for wave traveling in z direction is ei0 divided by modulus of eta e power minus alpha z. So cos of omega t minus beta z minus theta eta is the general equation. Now for air medium, this is a general equation applicable for all mediums. Now for air medium, it is ei0 eta naught, that means 120 pi. This is 1. So cos of omega t minus beta is omega root mu naught epsilon naught z, theta eta is 0. This is for air medium. This is for air medium. This can be written like this also once again. So average Poynting vector equation is equal to general equation half Ea0 square modulus of eta e power minus 2 alpha z cos theta eta az cap. This is general equation. Okay. Now this is half Ea0 square mod eta is nothing but eta naught, because that was real. In case of real, magnitude and without magnitude both are same, and alpha 0, e power 0 is 1, theta eta is 0, cos theta eta becomes cos 0 becomes 1. So half Ea0 square eta naught az. And if you write in terms of only, so this is for air medium. I told you that, dear students, ei0 divided by hi0 is equal to mod eta, but for air medium it becomes Ea0 by hi0 is equal to eta naught. So this is a general equation. And this is for air medium. This equation for air medium. Okay. Now you substitute this Ea0 is equal to hi0 into eta naught. If you substitute that here, then you get half hi0 whole square eta naught az. And if you substitute here Ea0 only, actually Ea0 multiplied with Ea0 by eta naught. One Ea0 by eta naught is written as hi0, that becomes half into Ea0 into hi0 into az. So it is like network theory only. Half Vm square by R, then half Im square into R, that means impedance, and half into Vm into Im, like that. Half is not there means here you have to take RMS values, dear students. So this is for air medium. So this is for air medium, and I am putting this in the box so that for air medium, this equation is for air medium, because you have substituted air medium parameters. For air medium, alpha 0, theta eta is 0, modulus of impedance is eta naught. So next discussion will be wave propagation in lossless dielectric, or otherwise it is also called as perfect dielectric. Okay. So dear students, let us see one observation. For air medium, we have seen for air medium, electric field equation is ei0 cos of omega t minus beta z, and magnetic field hy of z comma t is equal to ei0 divided by modulus of eta, that is cos of omega t minus beta z. It is written as simply hi0 cos of omega t minus beta Z, where beta formula is omega root mu naught epsilon naught y got. Anyway, I was telling you theta eta is 0. What is the meaning of theta eta 0? Electric field x component has cos term, magnetic field y component has cos term. Inside cos term, this phase and this phase both are same, so that phase difference become 0. That is the meaning. I will draw the diagram so you can see that. Now if I want to draw the electric field diagram with respect to distance, of course two variables are there here. Actually here total electric field is one variable, time is second variable, distance is third variable. Actually always we take one variable as a constant. For example, we take time as a 0. Zero time, at 0 time you are observing, that means whenever EM wave comes out of the antenna, then time is 0. At that time you are observing the electric field shape with respect to distance we will see. Okay students, so at t is equal to 0 time, electric field x component is EA0 into cos of 0 minus beta z, that becomes EA0 into cos beta z it becomes. Similarly, this also HI0 into cos beta z it becomes. Now, this one, when z is equal to 0 implies Ex is equal to this one EI0 into cos 0, that is equal to, that is EA0. When z is equal to lambda by 8, that means Ex is equal to EA0 into cos of EA0 into cos of beta is 2 pi by lambda into lambda by 8, that means EA0 into lambda cancel, pi by 4, cos pi by 4 is 1 by root 2 you get. When z is equal to lambda by 4, that implies Ex is equal to EA0 into cos of 2 pi by lambda into lambda by 4 you substitute here z, so lambda by 4 EI0 into lambda cancel, you get pi by 2, cos pi by 2 is 0, so you get 0 actually. So in this way you can substitute z is equal to lambda by 2, then you get Ex is equal to EI0 and cos of beta is written in terms of lambdas, so beta is equal to 2 pi by lambda and the z value is in terms of lambdas, so you get EI0 into lambda gone to cos pi is minus 1 actually, so that is minus EA0 you get, that is negative. So in this way you can substitute z is equal to lambda, that implies Ex is equal to EA0 into cos of beta is 2 pi by lambda multiplied with z is lambda, so you get EA0 into cos 2 pi, that is 1, EA0 you get. So if I draw the diagram, it is a simply cos signal, it is a cos signal. Okay, so I am taking the axis now here, this is actually x axis and okay, I will take like this. This is x axis. If I take here, then automatically this will be y axis, this will be z axis. So I am taking here z axis. Okay, z is variable. Now on the x axis I will take Ex, and on the y axis I will take Hy. Okay, I will take Hy. Now here z is variable. So this signal EI0 cos beta z, it comes like this, cos signal. Like this it comes. You can draw, you can proceed further. Anyway, make it symmetric. Symmetric बनाइए आप लोग. Okay. this width and this one should be same. So in this way here. So dear students, actually these lines are like this. You see, no? These lines are parallel to the Ex because electric field X component positive this side, X component negative downside this side. So vertical lines I am drawing means, what is the meaning? Electric field is positive this side, electric field value is negative this side. That is the meaning of that one. Okay. Now you can see here, whenever this is z variable, small z I am writing, whenever z is equal to 0, then electric field value is EI0. So this is EI0. Whenever again, whenever z is equal to lambda, again you got EI0, same value. That means here again you got EI0 here also. That means this is basically lambda. So z is equal to lambda distance, this one. Okay, students. Now half of that, this one is actually here minus EA0 is there. You can see here z is equal to lambda by 2 minus EA0 is there, this one. So that is lambda by 2 actually, this one. Okay, half of that, this one is lambda by 2 and this is lambda. So cause signal you will draw on the time axis. In that case, this is t by 2, this is t, but you are drawing on the distance axis. So this is lambda by 2, this is lambda. Now at t is equal to 0 time, here otherwise here implies hy is equal to hi0 into simply cos of beta into z, this one, hi0 into cos beta z. Cos of minus beta z you get, cos of minus theta is cos theta, you get this one. So this is similar to this equation only, but here in place of ei0, hi0 is there, and this direction was x direction, but this direction is y direction. So I am using reading for that. So here you have to draw the lines parallel to the y axis, this one, like this you have to draw. Highest value, this one, for example, this one, like this. Anyway, not exactly this one. This is EA0. This will be EA0 divided by eta naught. So some value is there. So like this, if I draw the lines, these lines are parallel to the y axis like this, and it is 0 here. So you have to draw like this. Okay. And similarly, here you have to draw the lines parallel to the, like this, this is parallel to the y axis, like this you have to draw. Okay. So if you draw in this way, once again it becomes like this, students. Actually it is a 2D board, but we are drawing a 3D picture. Don't bother about that one. Okay. Okay. And here it comes like this. So here these lines are parallel to the z axis, and ultimately these lines are here parallel to the y axis like this. Okay. But one thing, you make sure that whenever electric field becomes 0, at same distance magnetic field also becoming 0, because this equation and this equation are same. Now the phase difference between electric field curve and magnetic field curve is 0. That is the meaning of theta eta is 0. Theta eta is 0 means the electric field curve and magnetic field curve have same values at same distance, so that phase difference theta eta is 0. That means there is no shift in the curves. So here if you see the highest value is hi 0, and again same highest value is coming here for how much distance, that is lambda distance. Once again this distance is same actually. Anyway, here little bit tilt is there, don't bother about that. So here once again this is for this lambda only. This one is highest distance, you say, that is lambda only. So dear students, anyway here lambda is mentioned, na? That is more than enough, no need to mention again here. So dear students, here actually for examination there is no use of studying this one. That is why I wrote observation. Don't waste time by practicing this one. No use for examination. But some students confuse, sir, what is the meaning of theta eta is 0? To explain that, I draw this diagram. Anyway, I have explained this by saying in electric field phase and in magnetic field phase, both are same. So phase difference is 0. Mathematically, I have explained. Diagrammically also, I have explained now. Electric field equation and magnetic field equation have same values at same distance. So that means here shift is 0. For example, here 30 comes, na, then this red curve, that is hi 0, shifts for 30 degrees. That is the meaning of that one. Anyway, this is not useful for examination. Leave it. Forget about that. एक बार ऑब्जर्व किया आप लोग, फिर छोड़ दीजिए उसको, एग्जाम के लिए फायदा नहीं है. Now once again, let us discuss case 2 students. What is case 2? Wave propagation in the perfect dielectric. Perfect dielectric means actually sigma is equal to 0, or lossless dielectric. Lossless dielectric means alpha will be 0. That is the meaning of lossless dielectric. Actually, for perfect dielectric, sigma is 0. For lossless dielectric means alpha 0. Anyway, if sigma 0, na, automatically alpha becomes 0. So, when you talk of alpha, na, then you use the term called lossless or lossy, like that. Whenever sigma you say, na, sigma is not there in the dielectric means that is called perfect dielectric. Sigma not 0 means that is called as imperfect dielectric. Actually, for dielectric medium, engineers need sigma value 0. That is why they named that as a perfect dielectric. But in any dielectric medium, sigma is present. These engineers called that medium as a imperfect dielectric. Imperfect dielectric means sigma is present. Okay. Now anyway, for the perfect dielectric, parameters are epsilon is equal to epsilon naught epsilon r, and mu is equal to mu naught mu r. That means epsilon r value is also present, mu r value also can be present, and sigma is equal to 0. But for dielectric medium, in general, mu r is equal to 1. You remember that one. So in the examination question, if dielectric medium is given, mu r is not given, then for that you have to take mu r is equal to 1. So in general, for dielectric medium, dear students, for dielectric medium, epsilon r value is greater than 1. For magnetic medium, mu r is greater than 1. Dielectric medium is not a magnetic medium. That is why for dielectric medium, mu r is equal to 1. So for magnetic medium, mu r is greater than 1. But for dielectric medium, dielectric material is not a magnetic material. So that is why mu r is equal to 1. So in general, for dielectric medium, mu r is equal to 1, dear students. So this is important observation. In the questions, for example, wave travels in air medium. Air medium is not a magnetic material. And similarly, it travels in the cement wall. Cement wall is not a magnetic material. So that is why in examination most of the times you get the questions that medium is dielectric medium. In that question they won't give mu r value. If mu r value is not given, you have to take 1. But in any medium, in any question, epsilon r value is not given, you cannot take epsilon r is equal to 1. That is wrong. There is one formula to calculate epsilon r. I will tell you that formula. Keep observing carefully. Okay. Now let us start the discussion. So first one, you take gamma value, general equation, j omega mu sigma plus j omega epsilon under root. This is general equation. Now for what do you say? Anyway, for perfect dielectric, sigma is equal to 0. So j omega mu sigma 0 and j omega epsilon under root. So gamma is equal to j omega into j omega, outside j omega, root mu epsilon. Now this gamma is nothing but alpha plus j beta. So compare both sides. Here real is 0, so alpha 0 and beta is equal to omega root mu epsilon. For air medium, mu naught epsilon naught you got. For dielectric medium, mu naught into mu r, epsilon naught into epsilon r. Anyway, alpha 0 means it is lossless. That is why no loss is there. That is why it is called lossless dielectric. So lossless medium, or otherwise there is no attenuation. This you have to remember. And similarly, for this medium, intrinsic impedance is equal to j omega mu divided by sigma plus j omega epsilon. This is general equation. Now for the perfect dielectric, so sigma is 0. So 0 plus j omega epsilon, and ultimately j omega cancel. You get root mu by epsilon, that is equal to root mu naught into mu r divided by epsilon naught into epsilon r. So that is root mu naught divided by epsilon naught into root mu r divided by epsilon r. So here for this eta is equal to, this is eta naught, that means that is 120 pi root mu r by epsilon r. So this is the intrinsic impedance for perfect dielectric, and here also it is a real. So theta eta is equal to 0 for this one. It is not a complex. Whenever complex, then only theta eta comes. Theta eta is 0. That means for this medium also E comma H are in phase. In phase means they are in same phase. They have same phase. Their cause terms have same phase, so that phase difference become 0. Okay. Now let us talk of the phase velocity, student. Third one. So phase velocity general formula is omega by beta. Now for this medium, beta is omega root mu epsilon, and omega cancel. So this becomes root mu naught mu r epsilon naught epsilon r. Now 1 by root mu naught epsilon naught is c divided by root mu r epsilon r. Ultimately, students, this is very important formula. Phase velocity, listen carefully. Phase velocity is equal to omega by beta. This is general formula. But after doing derivation, you got c by root mu r epsilon r for dielectric medium. This is very important formula. I told you, in any question, exam question, dielectric medium is given and epsilon r value is not given, then this is the formula used to find epsilon r value. But in this question, they give omega value, they give beta value. So substitute omega here, beta here. C is 3 into 10 power 8. For dielectric medium, mu r is equal to 1. Then you can find the epsilon r from that. Similarly, in some questions, they give epsilon r, they give omega, they don't give beta. So this is the formula used to find beta also. In some questions, they give what do you say, epsilon r, they give beta, and they don't give omega. They ask you to find the frequency. So this is the formula used to find the frequency. Very, very, very important formula, this one. So I told you now that this formula is used to find one of the quantity. If omega beta is given, you can find epsilon r, because mu r is equal to 1 for dielectric. In the question they give dielectric. And I told you this is important formula. Now you have to observe that. Then whenever you read the question, okay, we have studied that formula, we have to use that, you must get idea. Okay, आपका दिमाग खुद आइडिया दे देता है. ज़्यादा ऑब्जर्व करेंगे पढ़ने के समय में, वो क्वेश्चन देखने में वो दिमाग फार्मूला को लिंक कर देता है. ऐसा ही पढ़ने के लिए बिना ऑब्जर्व करके ऐसा ही पढ़ते रहेंगे, फिर क्वेश्चन पढ़ने में आपका दिमाग है बिल्कुल आइडिया लिंक नहीं देता है फार्मूला को. आप लोग बोलता है आइडिया नहीं आ रहा है, आइडिया नहीं आ रहा है, क्वेश्चन सॉल्व करने के लिए बोलते रहता है. यू ऑब्जर्व मोर, बहुत ज़्यादा ऑब्जर्व कर लो आप लोग पढ़ने के समय में. आप क्वेश्चन देखने के बाद फार्मूला, कौन सा फार्मूला अप्लाई करना है, आसान से आपको आइडिया आ जाता है. सो स्टूडेंट्स, ऑब्जर्वेशन इज रिक्वायर्ड एक्चुअली. ओके, ज़्यादा ऑब्जर्व करना. ऐसा कैसे ऑब्जर्व करना? ये फार्मूला देखने के बाद C is 3 into 10 to the power 8, and I told you mu r is equal to 1 for what do you say, dielectric medium, then omega by beta. ये फार्मूला देखने के बाद क्वेश्चन सॉल्व नहीं करना, आप लोग दिमाग में इमेजिन करना. अच्छा, ये फार्मूला में ये दोनों देने के बाद ये फाइंड कर सकता, ये दोनों देने के बाद ये फाइंड कर सकता, फिर ऊपर वाला ये देने के बाद ये फाइंड कर सकता है. ऐसा आप लोग ऑब्जर्व करेंगे ना पढ़ने के समय में, फिर आप लोग क्वेश्चन देखने के बाद परेशान होने का जरूरत नहीं है. जस्ट ऑब्जर्व डियर स्टूडेंट्स. If these two are given, you can find this. If these two are given, you can find this. These two are given, you can find this. You observe in that way. That is called preparation actually. So if you prepare seriously when you are reading formulas, then in my view, no need to practice the questions, because practicing question is nothing but substituting the values and doing multiplication, doing division, doing addition. These things already you know. So now what is new? Remembering the formula and recalling that formula while reading that question is important. But you students only focus on substitution and calculations. You focus. That calculations are nothing. No need to bother about calculations. So this is very important formula. Next formula, lambda formula, also will be similar to this. So that lambda formula is this one. Lambda is equal to 2 pi by beta is general formula and for any medium. But for perfect dielectric, beta is omega root mu epsilon, that is 2 pi divided by 2 pi f root mu naught mu r epsilon naught epsilon r. So that is equal to 2 pi cancel. 1 by root mu naught epsilon naught is c by f and root mu r epsilon r. C by f is lambda naught. So lambda naught divided by root mu r epsilon r. Now actually for this medium, lambda is equal to 2 pi by beta is the formula, and you got lambda naught by root mu r epsilon r. So this is also important formula, dear students. For dielectric medium, they give frequency. This means this one, because lambda naught I will write here, where lambda naught is equal to c by f. This equation gives similar information. If you know frequency, then lambda naught is known and beta is given, and you can find epsilon r because mu r is equal to 1 for dielectric. So this equation both are used to find one parameter if other two are given. So this is also very important equation. Anyway, if you want that thing here, phase velocity for dielectric medium is always, you see here, C is 3 into 10 power 8. This for dielectric epsilon is always greater than 1. So denominator is greater than 1, then automatically this is less than 1. So phase velocity is less than C actually, because epsilon r is greater than 1. If you want, you can write this also. So in dielectric medium, phase velocity is always less than the light velocity because epsilon r is greater than 1. Denominator more than 1 is there. That is why. Similarly, this also same conclusion. Lambda is less than lambda naught. So lambda means I will write here if you want. Here also I will write Vp is phase velocity here. Phase velocity in the dielectric medium. Okay, here Vp means phase velocity in the dielectric medium. C means light velocity, you know already. Similarly, here also lambda is less than lambda naught because epsilon r is greater than 1. You see here now epsilon is greater than 1. So denominator is more than 1 means automatically this 1 will be less than this one lambda naught. So lambda is less than lambda naught. Here lambda is wavelength in the dielectric medium. Okay. Already in previous case I wrote lambda naught is wavelength of air medium or otherwise wavelength of free space I wrote here actually. Okay. I wrote there once again lambda naught is wave length in air medium or otherwise free space wavelength it is also called as, or otherwise it is also called as free space wave length. Okay, that is the meaning of that. So dear friends, now what is the electric field equation, what is the magnetic field equation, what is the power flow equation? There directly I am writing electric field equation is ei0 cos e power minus alpha, alpha is 0, cos of omega t minus beta z. And here magnetic field equation Hy of z comma t is equal to ei0 divided by mod eta. Mod eta is nothing but eta naught root mu r by epsilon r. Here na mod eta I have written here, this one. Magnitude of this is this one only, eta naught root mu r by epsilon r. Then e power minus alpha z is 1 cos of omega t minus beta z minus theta eta. Theta eta is also 0. So in both of them beta is means omega root mu epsilon. I am not putting them in the box. वो डब्बा में नहीं है क्योंकि जनरल फार्मूला याद है आपको, फिर ये याद रखने का जरूरत नहीं है. So average pointing vector for this medium is half ei0 square divided by modulus of eta means eta naught into root mu r divided by epsilon r into e power minus 2 alpha z e power 0, that is cos theta eta is actually 1 into a z cap, because e power minus 2 alpha z, alpha is 0, so that is 1, cos theta eta is 0, cos 0 is 1, so a z cap and watt per meter square. And no need to remember this also, general equation you know, that is half into ei0 square divided by modulus of eta into e power minus 2 alpha z cos theta eta a z cap. So for this medium mod eta is eta naught root mu r by epsilon r and alpha is 0, so theta eta is 0. That is why I am not putting them in the box, students. Now we are going to discuss case 3, that is wave propagation in the imperfect dielectric or otherwise lossy dielectric, because for imperfect dielectric sigma not 0, so in that case alpha also will not be 0, students. Okay. So students, now case 3, wave propagation in the imperfect dielectric, that means sigma is not 0 for this, or otherwise lossy dielectric, that means alpha not 0 for this, that is the meaning. Okay. Here medium parameters are like this: epsilon is equal to epsilon naught epsilon r, mu is equal to mu naught mu r, and sigma not equal to 0. But if you calculate this ratio omega by sigma by omega epsilon, this ratio sigma by omega epsilon ratio is much less than 1 you get for this medium. For a very good conductor, this ratio is much greater than 1 you get. For a very good conductor, sigma is very high. For example, 10 power, it is in the range of 10 power 7. For conductor, that is case 4 we discuss. For imperfect dielectric, this ratio is much less than 1. We have to use this property in the derivation. Then if you use this property in the derivation of the equations, then those equations are applicable for this imperfect dielectric. Okay, these are the parameters. Once again I told you, if it is a dielectric medium, in general mu r is equal to 1 for that. For a magnetic medium, mu r is greater than 1. So first one, gamma is equal to root of j omega mu into sigma plus j omega epsilon. This is general formula. Now what I am doing here, j omega mu, from this j omega epsilon we are pulling out, so sigma by j omega epsilon plus 1, this is root. So ultimately gamma is equal to j omega, it comes outside, so j omega square inside root, it comes outside j omega, then root mu epsilon, then this one minus 1 by j is minus j, so minus j, sigma by omega epsilon, root is there, so root is there means whole power half. Why in the textbooks they write like this? I will tell you. For lossless dielectric, sigma 0. If sigma is 0, then 1 minus 0 whole power half is 1. This is not there. That means for lossless dielectric we have seen gamma is j omega root mu epsilon, that was purely imaginary. So alpha 0 and beta is omega root mu epsilon. So now this is the gamma of lossless medium. This is the gamma of lossless medium. Now if sigma is present, then how much effect is there in the gamma equation because of this factor we have to observe. So this is the gamma of lossless medium. Now if sigma is present, now how much effect is produced, or otherwise how much change will be there in the formula due to this factor we have to see. So this is general equation. Now we know in mathematics one formula, if x is much less than 1, then 1 plus x whole power n is equal to 1 plus nx is the answer to this one. Similarly, I am putting this in the bracket. Here let us take this as a x. If I take this as a x, then what is the modulus of that? Minus j sigma by omega epsilon, that is nothing but sigma by omega epsilon. And for dielectric medium, this value is much less than 1. So this is much less than 1. That means if you take this as a x, then it becomes 1 plus x, where x is minus j sigma by omega epsilon. Then where modulus of x is this one, and that is much less than 1 for dielectric medium. That means this is a general equation. This is general equation. You see, here from this we got this one after doing some mathematics. So this is general equation. This is also general equation. In this general equation, if you substitute the condition of the imperfect dielectric, then we get the gamma equation for imperfect dielectric. So students, now if you take this as a x, okay, I am taking this as a x here, then this becomes a gamma is equal to j omega root mu epsilon. This one is 1 plus n is half, and x is minus j sigma by omega epsilon, because for imperfect dielectric is much less than 1, that is why. Okay, now actually students, if you want, I will tell you the calculation for imperfect dielectrics. For imperfect dielectrics, sigma is in the order of 10 power minus 17 students for imperfect dielectric in general. For imperfect dielectrics, if you are sending radio mirchi signal, then frequency is 98.3 megahertz. Megahertz means this much, that is approximately equal to, this is 100, so 100 into 10 to the power 6. Then if you calculate this one, sigma by omega epsilon value, sigma is 10 power minus 17 divided by, this is 2 into pi into f. F is 10 to the power 8, this one 10 square 10 power 6, 10 power 8. Then epsilon is 1 by 36 pi 10 to the power minus 9. Let us say epsilon naught into epsilon r. For time being, you take epsilon r is equal to 1, no problem. So 2 pi f epsilon, I have taken epsilon naught for simplicity. Now here 10 power 8, 10 power minus 9, pi cancel, 18, it goes 18 numerator. Then here 10 power minus 1, it goes there, 10, approximately 10 to the power minus 16. That means this value is very, very small. Really that value is very small. That is why we are taking that condition. ये है सच में, ये वैल्यू है फॉर डायलेक्ट्रिक्स बहुत कम रहता है 1 से कंपेयर करके, इसलिए वो कंडीशन ले रहा है. ऐसा नहीं है अच्छा लगता है करके नहीं ले रहा है. सो सच में वही है वैल्यू, इसलिए हम लोग उसको लेके डेरिवेशन कर रहा है. ठीक है, कोई बात नहीं है. नाउ that one, you multiply this one with this. Here j into j square is minus 1, minus into minus plus. So ultimately gamma is equal to omega root mu epsilon and half into sigma by omega epsilon. Next plus this multiplied with 1, you get same thing, that is j omega root mu epsilon, and here omega cancel, then you get half sigma, this one also cancel, you get root of mu divided by epsilon, this one you get. So omega cancel, half, then sigma, here root mu epsilon divided by epsilon square is there because it is outside the root, then one epsilon remains. So here plus j omega root mu epsilon. I am writing this gamma as a alpha plus j beta. Now compare, if you compare, then alpha becomes half sigma root mu epsilon by root mu by epsilon. Okay. So here alpha not 0. That means alpha not 0 here. So that is why loss is present. Okay. Now beta becomes omega root mu epsilon. So this beta is same as lossless. I will write like this. Beta is same as, otherwise this beta is same as lossless dielectric. Why I am writing like this, because velocity is equal to omega by beta, lambda is equal to omega by lambda is equal to 2 pi by beta, and phase velocity is equal to omega by beta. In velocity as well as wavelength, beta is there. That beta is same for lossless dielectric as well as lossy dielectric. That means in lossless dielectric and in lossy dielectric, in both the cases, velocity equation and wavelength equation are same. I am going to write that here. Now after doing this much derivation, what you have to remember, ये घर जाने के बाद पढ़ना नहीं है आप लोग, एक बार देख लिया वो बहुत है. Now what to remember after reading this much? This formula you have to remember, and this no need to remember. This is same as lossless dielectric case, and this you have to remember. Why to remember this one? In exam questions, they ask this one for imperfect dielectric. Alpha is answer 1 by 2 sigma root mu by epsilon. Okay, so here alpha not 0, so loss is present in this medium. Okay, this equation you have to remember, and this equation you have to already have remembered that one. This is same as, okay, loss is present. That is why it is called lossy dielectric. After discussing this much, you have to remember this one. Next, second one. Anyway, impedance, no, that impedance is equal to j omega mu divided by sigma plus j omega epsilon under root, that is complex because sigma not 0, so mod eta e power j theta eta. Here already I wrote, if you see in previous classes, I wrote mod eta is equal to exact value. I wrote root mu by epsilon. Without approximation, I wrote exact, that is 1 plus sigma by omega epsilon whole square to 1 by 4, and theta eta is equal to tan inverse of sigma by omega epsilon divided by 2. I am not putting them in the box. Already in the previous classes, I kept this in the box. Tan 2 theta eta is equal to sigma by omega epsilon, and no need to remember this one. So here, if you see carefully, in this case, alpha is also present, beta is also present, modulus of eta is present, theta eta is also present. That means the equations of electric field, magnetic field, and average Poynting vector, they are same as general equations. Okay, and let us talk of velocity and the wavelength. So phase velocity is equal to omega by beta, that is equal to c by root mu r epsilon r, and lambda is equal to 2 pi by beta, that is equal to lambda not divided by root mu r epsilon r. I was telling you beta, this one is same for lossless dielectric and lossy dielectric also. That is why phase velocity and lambda formulas are same as lossless dielectric. So these formulas are same as lossless dielectric. Okay, phase velocity comma lambda are same as lossless dielectric, because beta is same, because beta is same. That means, my dear students, until this, what formula you have to remember? Simply this formula you have to remember. This same as previous one, these are also same as previous one. Now, electric field x component for wave traveling in z direction is equal to EA0 into e power minus alpha z cos of omega t minus beta z, and magnetic field y component is equal to EA0 modulus of eta e power minus alpha z cos of omega t minus beta z minus theta eta. So, average Poynting vector half into EA0 square divided by modulus of eta e power minus 2 alpha z cos of omega t minus beta z, no, this one, so cos of theta eta a z cap watt per meter square. These are the these equations are same as general equations. Already you have remembered them before discussing the cases, so I am not putting them in the box. They are same as general equations because alpha is present, mod eta alpha theta eta is also present. So this is the discussion of the wave propagation in imperfect electric. I am telling you, you have to remember only one formula, that is alpha formula. Now, one simple discussion I am doing by taking this one. Observation I will write, then I will put in the box what is to be remembered. ऑब्जर्वेशन लिखूंगा, ये ऑब्जर्व करने के बाद बॉक्स में लिखूंगा क्या याद करना है करके. सो इलेक्ट्रिक फील्ड x component is EA0 e power minus alpha z cos of omega t minus beta z. Okay, students. At z is equal to 0 distance, electric field magnitude is EA0, because Z0 you substitute, EA0 into e power 0 is equal to EA0. At Z is equal to 1 by alpha distance, electric field magnitude is EA0 into e power alpha, e power minus alpha, z is equal to 1 by alpha, so that is equal to EA0 into e power minus 1. Now, electric field value becomes EA0 divided by E, that means EA0 divided by 2.71. For example, assume EA0 is equal to 1, example I am taking. Then in this case, it becomes EA0 into e power minus 1 is equal to 1 by E, that is 1 by 2.71. It is approximately 0.3. Electric field becomes 0.3. Power becomes e power minus 2 alpha z. Then power becomes 0.3 whole square. 0.3 whole square is 0.09. Almost power becomes 0. That means when wave travels 1 by alpha distance, then almost power becomes 0. Wave vanishes. Wave vanishes मतलब wave गायब हो जाएगा. So, dear students, for example, if we take EA0 is equal to 1, then this is at z is equal to 0. When wave travels for z is equal to 1 by lambda meters, then that becomes a EA0 e power minus 1. For example, if you take EA0 is 1, then 1 by 2.71, that becomes approximately 0.3. Then electric field becomes 0.3 when it wave travels this much distance. But power becomes electric field whole square. That means 0.3 square is 0.09. Almost power becomes 0. That means wave vanishes. So before dying, how much distance it travels approximately? The answer is 1 by alpha. So that is called as depth of penetration. Here depth means distance, or otherwise it is also called as skin depth. So now that is the definition given here. When wave travels z is equal to 1 by lambda distance, then electric field magnitude is this much, and that value becomes EI0 divided by E is 2.71. Now this distance, that is 1 by alpha, is defined as a skin depth. Symbol is given as del in Greek letter. So here definition is given. This distance is defined as skin depth or depth of penetration. Students, because of more lighting here, you may not see the letters. Don't disturb. I am reading them. So while reading, you can write, no problem. Because here now lighting is more. You may not be able to see here. बट ज़्यादा परेशान होने का ज़रूरत नहीं है. मैं लिखने के समय में बोल रहा हूँ, आप लिख सकता है. राइट. नाउ that del is symbol given for that, it is Greek symbol, and it is defined as 1 by alpha. Dear students, alpha is Nepper per meter. Nepper means no unit, that is constant actually. 1 by meter becomes meter actually. So the unit of this is meter. If unit is meter, na, that is called distance actually. That is why this is called as a skin depth. Depth means distance, or otherwise depth of penetration it is called as. So this is the formula for any medium. Dear students, in any question, if they ask you to calculate the skin depth, then what you do? For that medium, calculate the alpha value and take 1 by alpha, then you get the skin depth. So del is called as skin depth. Actually depth means distance. In general, this value is very small, this distance value. Distance is very small, that is called thin. Thin other name is skin. हमारा skin जो है बहुत पतला रहता है. Our skin is very thin actually. So that is why it is called skin depth. So del is called as skin depth, or otherwise depth of penetration. Skin depth or otherwise depth of penetration. So for lossless dielectric, for lossy, no, this is for lossy dielectric, del is 1 by alpha, that is equal to 1 by 2 sigma root mu by epsilon, that is equal to 2 times root 2 by sigma this one. Okay. Once again, I am not putting this in the box because you know del is 1 by alpha, and I told you for lossy dielectric alpha is half sigma root mu by epsilon. Again, no need to remember this one. So you have to minimize the formulas which you have to remember. Then you will be comfortable, dear students. So this is the equation. Now we are going to discuss one more thing here.